let's look at dealing with inequalities. So this section does equations and inequalities. This part is just about the inequalities. We have something new to do in this case. That in this one, we are going to learn to test regions. That's the new concept in this part. And I'm going to show you about how to do that. So the first thing to look at doing is that inside the square root, what are you not allowed to have? What's the domain of that? Okay, well, in particular, where is the beginning number you can't use? So x minus 2, you cannot have a negative in a square root. That's the whole key here. Cannot have a negative, okay? Not a negative number. So we have to take that x minus 2 and figure out what number would it be, x minus 2. And let's make that x so it really looks like an x. And we have to make it equal to 0. And so I add 2, and I say that x is equal to 2. Now x can't be, but that would be the 0 for it. That would actually be legal. What this does is this gives us one boundary. In reality, x could not be less than 2, because if it's negative 1, well, if it's 2, it's 2 minus 2 is 0. Square root of 0 is fine. If it were 1, and I put a 1 in here instead, 1 minus 2 would give me a negative 1, and that's not a real number. Or if I put 0, I get a negative 2, and square root of negative 2 is not a real number. Or any other number that's less than 2. But for this case, all I need is as a boundary. And I'll show you what I mean by boundary in a second. That's supposed to be RY. In fact, I am going to rewrite that word so it's clear, the last part of it. All of it. Almost. Boundary. Because we're going to use that as a boundary for a region. All right. Now, having done that, the second part is to simply solve it as normal. Solve as normal, as if it was an equal. Okay. So x minus 2 plus 4. Some people like to put an equal there just because our goal here is to get what x would make it equal. And we'll deal with the inequality in the third part. So I'm going to do that here. And so I first have to subtract 4. So it's cleaning it up before I can square root or square both sides. 7 take away 4 is 3. Now that allows me to square that side and also square this side. So x minus 2 is equal to 9. Okay. And what I'm finding out is I'm running out of some room here. I guess I'll work it out on the other side. Okay, plus 2, x is equal to 11. Okay. So what this is doing for me is coming up with a second boundary. Second boundary. So now over here, I'm going to do the third part of this. And the third part of this is to make a little number line and to put these two numbers as my boundaries. So I don't have to put all the things for it, but I would need to put 2. Actually, need to leave some room to work. So I'm going to put a 2 there and say an 11 here. And that's going to be my 2 boundaries. And I need some space to work with because, let me take these out because I have to show that's an 11 there. What I have to do now is test the different regions. Okay, so I am going to put a number here. I have to pick a number that's somewhere over here that's easy to work with. So a 0 is almost always an easy thing to work with on it. Okay, and then 2, 3, I say between 3 through 10, either 3 or 10 would be good ones to use, maybe even 5, but 3 smaller, so I'll put it there. And here, 12 is probably the best one. I am going to come back up to this, and I'm going to put those numbers in and test. Is it a true thing because of this less than? Do these numbers make it true or false? So in the first case, I'm going to have, if I put 0 in here, 0 take away 2 is square root of -2 plus, it doesn't matter what I do. Square root of -2 is an impossible thing to work with. It's if you want a real answer. And therefore, this is no good. We can't use that side. It's false. It's not possible. All right. Or you just don't have to deal with it because you're going to get an imaginary number. Now let's do it with a 3. If I put a 3 in there, square root of 3 minus 2, I get square root of 1. And so I get 1, and square root of 1 is 1. 1 plus 4 less than 7. 5 is less than 7. This is true. This is a good part. True. Okay, so right now in here, this part is good here from 2 to 11. For the 12 now, let's put it in with the 12. If I do square root of 12 minus 2, that gives me a 10. 12 minus 2 is 10. Okay, so square root of 10 plus 4 less than 7. So this is where I'd have to use a calculator and see if I could choose other numbers to avoid having to have a decimal, but it's going to be sort of okay to do it. Many times you might as well just go with that number. The square root of 10 is 3.16222. So I can round it to 3.16. Or I could round it to 3.2, but I think I want to get about as close as I can. But 3.16 plus 2 is 7.16, and that is not less than 7. That's greater than 7. So that means this side can't be used. So what that means for our answer is what we have to do is take into account that x is between the numbers 2 and 11. I want to make this a little smaller so that I can use more things, do more things down here. Here's 2 and 11. The x's I can use are between those. Okay? And because that's a less than sign, I would do that with the 11. But over here with the 2, if I did the 2 in there, I get 0. I can make that equal to the 2 because 2 itself can be used and make this correct. 11 cannot because it would make it exactly 7. If I put an 11 back up here, I'd get a square root of 9. That's 3 plus 4. That's 7. The 7 is not less than 7. That's not true. 7 is not less than 7. It's only equal to. So the 11 can't be equal to, but the 2 can be. So this is one answer, or one way to answer it. Or you can do this in interval notation, which is the preferable way to do it. And that would mean putting it as a 2 because that is included and an 11 because that is not included. And so either of those would be acceptable unless you're told specifically to do interval notation. When in doubt, do interval notation. Now, step 1 was determining which x's are allowed or where the boundary, the first number is, the boundary for the square root. Second, solve it as normal as if it was equal and get the second boundary. And then third, use the 2 boundaries or 3 or 4 if there were more answers to it to check the different regions. So you're testing regions to determine where you have good answers or where you do not have good answers. And then write it out like we did here. I guess we could call this a 4th step, is to actually figure out the way to write it. Down here, there's a very similar type of problem. Looking at this example and memorizing the steps, now do this one yourself. Pause the video to work on it and then come back and I will work it out. Pause. Welcome back. Let's go ahead and do this one. I'm going to do +9 first. Oops, wait a second. I think the first step is to take what's inside the square root, x plus 5, and figure out what would make it a 0 there so we know our first number. minus 5, x equals negative 5. And there we are with our first boundary. Okay, so that's our first one. We can't forget about that. The second thing now is to solve this just like normal. Okay, so I've just added 9 to both sides. I have the square root of x plus 5. And I'm going to do it as if it was equal. Negative 7 plus 9 gives me a 2. Okay. And so now what I get is to square both of these. I think I want to rewrite it first. Well, actually, I have enough space down here to do it underneath it. Square it and square it. I have x plus 5 is equal to 4. Subtract 5. X is equal to negative 1. Here's my second boundary. I have 2 of them. So now, by the way, if this was set up differently and say it was a quadratic or something, I might end up getting 2 answers to it, in which case I'd have 3 boundaries, because I have 1 over here, and then I have 1 here, but I might end up with 2, in which case I'd have more boundaries. And now down here, I will do the third step, which is the number line, and I'm going to have, negative 5 and negative 1. So let's put negative 5 here and negative 1. And we want to pick numbers that would work to help us. Oh, come on, get in there. Okay. So I want to see whether these numbers, pick numbers that I can see would be right, would help us determine if the inequality is correct or not with those numbers. In between negative 5 and negative 1, probably negative 2. And over here, I'll do 0. I could choose any number. For this one here, I could choose negative 8 million, except it's going to make for a very hard problem to figure out. So let's not do that. All right, so with the negative 6, I'm going to put that in here. Well, as soon as I do negative 6 plus 5, I get a negative 1. I know I can't go any further. So this whole region here is no good. Okay. Oh, and I want to do this. Now let's put negative 2 in here. So I have the square root. Let's see, what is it? Yep, plus 5. So I want to take that. I'll make this a little smaller just so I can see that to start with. I am looking at this here. We go back to the original with the less than. So I'm going to do negative 2 plus 5. Keep that negative separate from the 2. Negative 2 plus 5 minus 9. Is that indeed less than negative 7? This is a question mark. Are we going to see, we're going to see whether or not that's true. Well, negative 2 plus 5 is a square root of 3. Minus 9, less than negative 7. Well, the square root of 3, when you put that in the calculator, comes to about 1.7. So that's 1.7 minus 9. Well, let's calculate that. Okay, square root of 3, 1.73205, and so on. I'm going to subtract 9 from it, and that's going to be negative 7.2679 or 0.26 or 0.27, I guess. And that is indeed less than negative 7. That's to the left of negative 7 on the number line. So that means this area here is all good. And I don't actually want to check quite so big, but this one we're good on. Okay. Oh, I don't want that all to go away, but I do want to do that check. Now let's put 0 in here. All right, so we have square root of 5, 0 plus 5, minus 9. Is that less than negative 7? Well, square root of 5 minus 9 less than negative 7. The square root of 5 is 2.236, about 2.2, 2.24, minus 9 less than negative 7. Well, that take away 9 is about negative 6.76. that is not less than -7. That's greater than -7, which means this area is no good. And the only area that's good is here where the x's are between the -1 and the -5. Okay, -5 and -1. Because that's a less than, we have less than. Now with the -5, if I put -5 in here, if I put -5 in here, I get square root of 0. That's legal. I can do the square root of 0. And so that means this can be a less than or equal to. So I'm going to have two answers. I'm going to have -5 less than or equal to 6, but less than -1. Okay. And, or I'm going to have -5 goes to -1 and doesn't include -1 for interval notation. So these two answers, but this time I'm only going to yellow in the interval notation one because I would prefer that you do it that way. I won't take off if you do this one unless I specifically say do it interval notation. So pay attention to the directions for those. So these two examples show how you set up regions after you figure out the boundaries. By the way, sometimes it's going to be on opposite sides. If I had done this one as a greater than or equal to, I would have ended up actually going out this way. This one would have been correct, and this one would have been correct, and the inside would have been wrong. So in which case, we would have had two different ones. We'll look at that one another day. Hopefully, this helps with understanding about doing these regions. All right. Thank you for watching and listening.